Well, let's see. I think that'll work. Thanks for tuning in and welcome back to the shop. This is our 2013 Mitsubishi Fuso FG that I'm slowly turning into an Overland camper. Now that I've got progress on the deck for the outside of the door, I think it's time to start working on the shower pan for inside the door. That's right, this empty space here in the floor isn't just unfinished. The idea here is to allow us to insert a shower pan below the floor level so that we can end up with a flush floor here with a shower pan under it. It's time to break out the stainless steel and the TIG welder and see if we can make a shower pan. The recess in the floor is approximately 24 inches wide and 48 inches long. And I just happen to have a 31 inch wide by 48 inch long piece of stainless steel. It's about 3/32 or about 2 millimeters thick, which is a little bit thicker and heavier than I would have used, but I have it and it's close enough to the right size that I'm gonna try to use it. Now I will say before I start this, I am not very experienced at TIG welding stainless. Aluminum I'm fairly comfortable with now, not professional, but comfortable. So we'll see how this goes. In order to minimize the amount of welding that I need to do, of course, I'm gonna try putting in as many bends as possible on the longest corners. Longest corner, that doesn't sound right. On the longest corner sides, on the longest sides, I'm gonna eliminate as many seams as I can. Meaning I'm gonna put a long bend on this side and a long bend on that side, which will end up being this long side here and this long side here. Now the pan is also going to be tilted so the front is going to be higher than the back so that the water drains to the back end, which makes it a little bit more complicated because it's not just going to end up as a rectangle with 4 folded sides. Because the pan will be shallower here and deeper here, the side needs to go from tall to skinny as we go forwards, which essentially means that one end of this is going to be wider than the other, but the bends are going to be parallel. I did think of this when I made the floor structure of the truck, so this center rib should be at the right height so that when the pan lands on top of the center rib and on top of the forward rib, it can actually drop down ahead of the rear rib, which gives us hopefully a decent slope for the water to run from the front back to where the evacuation pumps are, even if the truck is on a little bit of an angle. So with that slope set in place, I know that the front of my pan is going to be about 1/2 to 3/4 of an inch deep, and the back is going to be about 2.5 to 2 3/4. And that variance is depending on how much I want the edge of the pan to be below the edge of the floor. Because where this green tape is, I'll have a floor flange that comes over and then down to overlap the edge of the pan that goes up behind it. Hopefully that'll let me get a nice clean finish at the transition between the floor and the pan, and also give a bit better of a watertight finish. Anything that's landing on it can run down the trim and into the pan versus landing on the top corner of the pan. With all that sorted out, I need to do some layout lines on the stainless sheet so I have something to follow. It's not too complicated, hopefully it's right. I've got 2 options on what I could do next. I could cut the edges off so they have the right angle and then bend it, or I could bend it and then cut the sides off. My vote? It's time to set up the press brake. My main reason for choosing to do it that way is I would much rather be able to test fit the pan with the sides still high and make sure that I've marked it properly than cut them, bend it, and then find out that I should have cut it lower or higher and have to do it again. This is my 35-ton air-over-hydraulic homemade press brake. It doesn't do a lot, but it does a decent job of bending 90-degree angles. It's not a very complicated piece of equipment. It's a bunch of steel I-beams, a 35-ton air-over-hydraulic jack, and some pneumatic cylinders to lift it back up. The tool, or punch, is made out of 1/2-inch plate that's welded together. They were bought online. The die is a piece of 2x2 steel angle. I won't be making anything super precise in it, but it does the job most of the time. To insert the tooling into the top half of the press brake, I need to start by lifting it off of my rest blocks, which is as easy as adding some air to the air cylinders, and up it goes. With the blocks out, now when I lower it down gently, it should land on top of all these, and then I can clamp them all in with the bolts. The pieces generally don't all line up perfectly, so some persuasion is needed. Ah, that bolt's tight. That's why. Let's try loosening that off. There we go. So that gives us 48 inches of tooling in there. Now I just got to go and carefully tighten all those up to hold them all in place. I start tightening with my cordless drill as it doesn't take much torque, and I'll finish them all off by hand. And now with the tooling all tightened in place, I can lift it back up with the air. Put my stops back in so that I can put my piece of metal in and out without being scared of losing my fingers. My press brake isn't fancy enough to have back stops or front stops or anything, so setting the part in is a completely manual process. My choices are basically measure from the front to the outer corner, or from the back to the back corner, which is a little harder to get at, and make the bottom of that punch line up with this line. Which brings up another good point of this line. That's my cut line. If I had decided to do the cut first, I would have been very close to the back corner of the die, which may have resulted in an uneven bend. And remember, my bends are parallel with the sheet, or with the side of the sheet, so it's very easy to take a measurement from there to here, and there to make sure it's all the same, so that I know that my two bends will be parallel. With the part pretty close to in the right place, I'm going to take my safety blocks out and lower it down so it's just resting on the top of the plate, and then I can make some final adjustments to fine tune it. That should be good. Now, there's my first adjustment needed. I'm not quite in the right place. So this should just need a tiny bit of air to take the weight off. And then we can slide it down that way. And then double check the measurements. I do have a small air leak in here, hence why I had the safety blocks in there. So it's just dropped down again, which is fine. You can take some measurements. I'm pretty sure it's in the right spot, but we'll double check it. 27 1/4 and 27 1/4. It's a little bit hard to see, but I can also tell that I'm right on the mark that I left with the Sharpie there. And you can just see the edge of it right there. So we should be good to make a bend at this point. All I need to do is release the rest of the air from the lift cylinders and then start giving air to the hydraulic jack. 35 tons of force makes a pretty quick bend, but it also uses a lot of air, so I need to bleed a bit of air off to kick the compressor on to bring the pressure back up to lift it off the part. Well, the first bend is done and it came out basically as expected. I was aiming for a slight underbend, maybe not quite as underbent as I got, but I think I can make it work. So what I mean by that is we didn't end up with a 90-degree angle, we ended up with a little bit less. And the reason I wanted to do that is I actually want the bottom to be a little bit narrower than the space, and I'll show you why. Because if we make it the full width at the bottom, we're going to run into issues with the welds, and it's always easier to have something that fits in that is sort of a taper fit. It gets tighter as it goes in. So what we end up with is a bend that's about, or a part that's about a 1/2 inch wider at the top than it is at the base, which should work nicely because I measured 24 at the bottom inside the welds and the top is actually 25. So if we gain a 1/2 inch on each side, we're gonna end up flush at the top and inside the welds at the bottom. Now there is one thing that I didn't quite get right, and that is the radius. I was expecting this to be significantly tighter, which means my overall part will end up wider. But that's fine because I can adjust the bend on the other side to be a little bit narrower. And if need be, I can probably put this back in and get that bend a little bit tighter, but I think I'm pretty near the limit of what this machine can do at 35 tons on this length and thickness of stainless. So now I'm gonna flip it around and bend this line here. I'm gonna go just in from the line, just so we don't end up with a part that's too wide. Slightly narrower is okay, slightly too wide is not gonna fit. That is under a lot of tension right now. Oh, fire call. Okay, well luckily it's not a call from my station yet. Could become one, but right now I can keep going on bending this, so let's pop it back out and see what our overall dimension is. Hopefully I got it close to right. To lower it, I just take the bottle jack handle and release the pressure on it by twisting it. And once the jack comes down far enough that it's not in contact with the beam anymore, it should be right about there. Then we can apply the air pressure again. Hopefully, there's probably not enough left to lift it up, so I'm gonna have to bleed off some air to let the compressor go, but we'll see what happens. Up on the air. There we go, it released the plate. All right, let's see what our dimensions are. Actually, let's go one step beyond. Why not just stick it in and see if it fits? Just gotta move the fridge. That's heavy. Of all the things in this build that I'm trying to save weight on, I guess this won't be one of them. But in reality, it's down low and it will be nice and strong, so it's not overly concerning. As long as it fits. Not too bad. And you may notice that we're sitting on top of the floor here, and you may recall that at the beginning of the video I said it's about 24 by about 48. Well, it's 47, which is about 48. So now what I need to do is make a bend here. So I'm gonna hopefully bend this up, and then all I have to do at this end is weld the corners, whereas at that end, I need to weld the entire end on. In order to make this bend, I'm gonna have to do two things. One, I'm gonna need to cut this and flatten that piece back down again. And I'm gonna have to change the pressed brake width from 48 inches to 24. And actually, I've decided that now that I've test fit it, I'm safe to trim the sides off. The excess material that I cut from the large side is what I'll make the end cap for the deep end of the pan out of. I'm actually going to try something a little bit different from what I had originally thought because I'm not a bender fitter. I was going to flatten these corners all the way. Instead, what I've decided to do is kind of offset them. I've pushed them out a little bit and pulled these in a little bit so that we get an overlap when this folds up, and then I can just zip disc through both of them, which should give me a nice clean fit for welding it. Well, I think that worked. What we've ended up with is a nice radius corner, and then I'll have to trim it so that this fits here and my weld will be just away from the corner, and then I'll just have a little hole to fill there. Same on the other side. Just got to trim it basically where my original height line was and bend it in. We'll just bend them in to match, and then weld that corner up. And after a little zip disc action, our corner looks like this. Just a little hole down in the back corner that we'll have to fill. And the opposite side looks like that. So let's give it a test fit. Just need like this much of a trim on the edge of the floor down here, and it'll drop in. Actually, maybe not quite touching the other end yet. There we go. That's in. So pretty much flush with the floor here. I might have to just take a skim off of here with the flap disc, and then over here, once it's welded, I need to cut that last 1/4 inch off, which I needed to do anyway to make the end even with the side. Down under there, we're right back to the welds. And this whole process is taking me way longer than I was expecting, so that is as far as I'm gonna get today. And unfortunately, that means I'm not gonna get to trying to weld the stainless steel today. So make sure if you like that video, you hit thumbs up, hit subscribe if you haven't already so you don't miss me welding it together or trying to. Thanks for watching, and we'll see you next time.